is about testing.
Testing in production? Isn't that like not testing at all and just hoping it works in prod?
Not in this case. Our next speaker, Igor Kapkov, will be sharing with us the Branch By Abstraction pattern and associated tools to give you confidence when shipping code. Didn't you work with Igor?
I did work with him recently at Zepto, where Igor was the finalist of the Finnies 2022 as Emerging FinTech Leader of the Year. Igor is the founder of Refactorly, a developer tool that helps teams move faster with confidence. He's an experienced CTO who has worked with governments, FinTech, e-commerce, social networks, helping them scale, former Homebrew core maintainer and active open source contributor.
Does he pair?
Well, I talked to Igor and he says he's over-pairing with developers.
What?
He would, yes, he's past that and he's now pairing with customers by testing in production.
Ooh. And a speaker sponsor moment for us, Igor, proudly sponsored today by Invisible Light. Thank you, Invisible Light. And all the speaker sponsors for helping the speakers come along today and be part of this amazing conference. Igor Kapkov, testing in production. There is a better way.
All right. Hi, everyone. I hope you're having a good time as much as I am here at the conference. It's great to be back in front of the audience. And I wanted to extend my huge thank you to the organizers, volunteers, MCs, and the AV team at the back. And my name is Igor. I'm a founder of Visible Light. I've been developing software for about 15 years and love sharing my knowledge. So the slides are already on my website. If you want to follow along, I'm not as trendy to move in at the Mastodon, but you can follow me on Twitter. I'm on the Mastodon also, but don't post there often. And I'm happy to take questions at the end of the talk, but feel free to catch me after that or over the Twitter. I like to discuss the topic further. Today I will be talking about something that is near and dear to my heart. It's refactoring code with confidence. The concept I will show you is actually like very simple, but to understand like why we get there and how we get there, we need to understand what problems do we solve and what benefits we get out of it. But first, let's start by a bit of history, and let me tell you a story. This is Basilica della Sagrada Familia. It's the longest construction project in the world. It started in 1882 by architect Francisco de Polo, and within a year after starting the project, he resigned, and Antoni Gaudí started. And a year later, he became the architect director. Interesting, right? Like he's joined, but haven't been appointed the architect director immediately. Almost 40 years later, Gaudí died, while the project was finished only 25%. In 1936, 10 years after Gaudí's death, there was a Spanish civil war. And anarchists set the fire in the crypt. They also broke down into the Gaudí's workshop, and they destroyed partially his plans for the Sagrada Familia. So in 2017, the current team said that they want to finish the project by 2026. They wanted to do that to celebrate the 100 years since Gaudí's death. But in 2020, COVID-19 happened. And we don't have a new completion date, but they are sure that it won't be finished by 2026. And like over time, it's interesting how like technology changed. It's a really long project. Right? Originally, they were getting the sandstone from particular regions of the world, and they can't anymore. So if you can see on the photo, the color of the sandstone in the building is actually different. So I don't know about you, right? But I've seen that a lot in our industry. We get the CTO or an architect, and they get frustrated after a year, or get the better offer, or management is not happy with that, whatever the reasons are they live in. And the team is going without one. So we keep going, and after a while, one of our peers gets promoted and becomes our new boss. And they try to put the long-term goals because they saw how it ended before. But there's always something. There's new features, there's new customers, there's a third-party outage. And then we have a relatively successful project, and our customers is using the project on a regular basis. Now, like management will come to us and ask to do something new. But it doesn't fit our current architecture. Or we have a scaling issues because we got the investments, we expand to the new regions, and we want to improve our performance. Whatever the reasons are, to make these changes to the live environment that might affect many users, we need confidence. And I don't know what you've been told or how you've been taught. Changing code is easy. You just go and change it, right? Like changing the code with confidence and knowing that how it will work, that's the hard part, at least for me. So why developers are afraid of refactoring? The startups built in Rush, and now they have the customers. And you know what the customers hate? When their workflow is broken. I remember the time when we were switching JSON serializer. It was actually when Samira and I was working together. And when we changed, we realized like the customer started complaining that there's a problem, there's a key missing. And for some reason, the new serializer decided if there's a nil value, it will drop the key. So I think the two main problems why developers are afraid of refactoring is we don't know how some pieces of the software works. Maybe it's a long-running project and you recently joined the team and want to, and you got the ticket and you need to change. And you're like, I don't know, I haven't worked with that before. And it's important, right? It's a critical piece of software that desperately needs some love. And if it's done wrong, we will lose the reputation, there will be like loss of revenue, and there will be angry boss. The code that really needs to be refactored is fragile. It's mission critical, and no one wants to touch it. What do we do to increase the confidence? I think that's what the tests are for, right? So let's talk about them. Who is here 100% confidence with their test suite? Please raise the hand. All right, same there. There's a one hand just for the recording was raised. So, and yeah, I actually even know the few people here who have like 100% code coverage by lines. And I can assure you, they're not confident, like their confidence is not as high as their test coverage. And the problems with tests, right? Like we write a lot of them. When we develop the features, we find the bugs, we write the more tests, and over time, this just grows with us, right? And what are the I see as the problems with tests? Most important, in my opinion, is the data quality. The tests that we write, they are synthetic. They're pure. They're not a representation of the real world around us. How many of your tests test historical data from like 5 years ago? There's a couple of hands, right? Remember that validation we forgot 5 years ago? And like everyone was submitting the data over the form, or it was the import? It is still there. But it's not in our tests. The next thing is related to that. It's a best effort. Getting a real test coverage is hard. And you know that test that when you do something, you fix the bug, and the test fails. And there's a description preserved for backward compatibility. And some people called it backward compatibility. It's like a best effort that represents the current state of the system. Everything that your manager or whoever wrote the ticket thought of, how it will be used, everything while you were developing and asking a question that you thought of, you put in a test case. But there's will be something more always. Otherwise, there would not be bugs at all, and we will be out of job. So there's also 2 more points. It's costly. It's costly for your productivity, for your developer experience. No matter how experienced you with the tests, it's still there, right? You need to run them. There's a start time of some particular frameworks. And it's also costly for business, literally. There's great companies that have CIs that's sponsoring the conference, but it's still, you need to pay for the CI, you need to pay for servers. There's many things involved in running CI/CD and like your tests constantly. And again, to circle back, it reduces your productivity and the time to market. So we briefly touched on the data quality, right? Like, let's talk more about it. So for the why we need data, right? We need data to inform our decisions. And for the purposes of this talk, we need to look at the 2 parts of that. The first one is inputs. What I mean by inputs in this case is like, do we have enough use cases covered? And tests are notoriously bad for that. And we saw that from the previous slide. The other part of that is the outputs, right? How do we know that the code that we ship, the new code, is better? Is it still correct? That's where observability in the metrics and like new DevOps practices come in. But I think there's some particular flaws for the purposes of my talk that is missing in the common practices of the observability, and I'll mention them a bit later. So what do people do? They test in production, and it's a software development practice, right, where we, instead of like sending that to the QA team and testing that on staging, we test that in the production. So our users see that, we look for that for the metrics. It's like trunk-based development, so we look for metrics and exceptions in the error reporting monitoring, and so on. Or just manager tells us that customer's code. Right. So what is the status quo of testing in production? And I think the main 3 things that people do is they use the feature flags, they use canary deployments, and they use A/B testing. And I want to pause here, and I really don't get how we get to this point in the industry. It's debatable, is it art or a science, but we, as engineers, we came to the place and we're like, yep, that's okay to the subset of users, submit the bugs. And let it just like fail for them, the rest are lucky. It's also not the real performance monitoring, right? When I mentioned observability before, what I meant is usually it's a test over time, right? Like you're like, okay, this request is slow. We want to improve that, and it's like a month later we look at the new graph, right? But there's so many factors involved that affect these graphs. I had the examples when my team thought they fixed the major performance bottleneck. And the graph's aligned. They shipped it. It's aligned. Monday morning, we don't ship on Friday. And that wasn't the fix. What actually happened is the problematic customer that affected this graph, they went bankrupt and stopped using us. And we also do agile, right? Why does the refactoring or like rewrites is still waterfall? Like when we're all done, when we just flip the switch someday, 3 years later, maybe, the priority would not change, of course. Does that sound familiar? I prefer to have gradual benefits as soon as possible. And we can do that with science. So the scientific method was around for a long time, and it consists of, we formulate the question, we do the hypothesis and prediction, we test that, and we do analysis on the results. And as a developers, I think it's just like it's a normal flow, right? We make the hypothesis, whatever I wrote, I think it will work this way. And when we do a big rewrites, this is usually how it goes, right? We write the new functionality, we dark ship it, we start double writing, right? Because we adjust some data. And we migrate the legacy data, and there's a bug. The data will diverge, and we migrate again, and we double write again, and we find the bugs in the old system, in the new system, and we repeat the process. So that's where the scientists come in. The scientist is a library by GitHub. It's based on the branch by abstraction concept. And the scientist is not the library for writing tests and not supposed to replace them. Please, please, please do write the tests. It's a tool for carefully test alternative code paths, but in production. The reason we can safely take this approach stems from the fact that the experiments still use the result of the existing code that's known to work for your customers. And the code is only evaluated, the new code is evaluated alongside the new one for the observation and the comparison purposes for both the accuracy and the performance. It works best with existing practices, so I don't say that stop using the feature flags or canary rollouts, but if you add the science to that, it will be better. So let's see the code example. That's only 4 lines of code that I will be presenting. And I will walk you through it, but like I want to get back to my first word, right? It's like, what I want you to get out of this talk is that this code is not that important. The idea is very simple, and the technical part of the problem is simple. But many people, I think due to this simplicity, many people overlook it. And that's why I spent the full talk giving you the context and why we get where we are right now, and how the scientists compare to the other testing and production solutions. So this is the original scientist example from their README. And let's take a look at it. So we have we give the experiment a name. In this case, it's widget permissions, and it's just the metadata. And we pass the experiment object into the block. And the body of that block is the so it has 2 methods, right? It has use and it has try. The body of the use method is our existing code that we know is working, and we want to replace with the new one. And our theory is that the block in the try is better, it's more performant, it has less memory allocations, or whatever you're optimizing for, and the reasons why you refactor it. And let's take a look. Like what will happen when this code is executed, right? Let's assume it's a part of Hanami action. And when the user makes the request, the block will get executed at the random order. So it's either use or try will be ran first. The result of the use block will be returned to the user. And if anything happens in the try block, there's like an exception, it will be swallowed and the user will not notice it. Right? But because at the same request, they were running both at the same time, we know that when we compare the results of this execution, for the performance reasons, we know that our database was on the relatively same load. The request came to the same load on your compute, and so on. Right? It's in exactly the same conditions rather than behind the load balancer on your staging environment. And there's many more DSLs for that. Right? Like one of the things and one of the main things that it does, when it's finished the execution, it runs the hooks that are sending the data where you want, and you can define that. And you can send the metrics, and you can also send the results, right? So we can add the contextual metadata, and like the user ID in this example, for example, and compare that, like, did it return true or false? And when they differ, we can show the diffs. For more complicated examples like a search, we can compare the search results in the diff. And what it means, and like for our users, there's no difference in the behavior. They will not notice that we're experimenting with the results. But for us, it's just a gold mine, right? Because our users, they generate the use cases for us that we have not thought about. There's a saying, right, that if we ship our product, the users will find a way to break it. Oh, thanks, please do, and we will fix that, and it won't be broken for you. There's much more to the scientist itself. Please check out our docs at Visible Light or Scientist README to find what else you can do with it, including the conditional runs, rollouts, and like the comparison logic, how you do that, the sanitization of your PII, and so on. So let's step back and like look at like who is using the scientists, right? Here's some companies that use scientists. There's much more. I expect, based on the contributions, there's some more like big companies in the Ruby world specifically that using that. But originally it's being built at the GitHub and was written by John, Jesse, Rick, and Nathan. And that team at the GitHub were working on the permissions that have been rebuilt from the ground up for over 3 years across the whole project, while like getting benefits every day. Another team at GitHub changed one of the main parts of the app, right? Like the merge button when we write. They completely rebuilt that using the scientist. And I want to quote their blog post. So to sum up, in roughly 5 days of the part-time work, we replaced one of the GitHub's more critical code paths with no user-visible effects. The another company here is Trello. They, not Ruby company, but they maintain the most popular JavaScript fork of the scientist. And the original implementation in GitHub is in Ruby. And they also maintain official C# library. And there's many forks for many languages. From my experience with scientists, I switched JSON serializers after this example that I mentioned of breaking the customer's experience. I was in the team where we were switching Postgres to Elasticsearch. And I also switched Active Record to SQL for the ORM. I think if you're a professional consultant who is coming to the project and you have a limited time and you want to bring the value to that customer and have a positive feedback and maybe renewal of the contract, I think there's no better way to do it than the visible light, to figure out how the system you start working with react to the change, because you're new to the domain and you want to improve because you have an experience as a developer. But if you use the visible, right, you don't break that, but you see how you can improve the edge cases. And Nate yesterday was mentioning the SSL in Puma, right? I think that will be another great example of using that. It's harder to do in an open source project because shipping that, but you can monkey patch and use your own SSL implementation and compare that the encryption is one of the great use cases for that. Another company here, the CipherStash, if they decide to rewrite their Rust implementation in Zig or NIM or whatever they want to, they can compare that their encryption have not broke in between their libraries. Right. So now I would love to address some myths that I've been talking to a lot of customers around it through my customer development interviews with the clients. And one of the myths is you can do that in staging or sandbox. But as I mentioned with observability, right, it's not the same traffic. It's not the same data. You have different loads. So I'm not sure what you're comparing if you do that. If you have a great QA team, they will find something. But you also would need, if you want to do it better, you need to anonymize the data and copy that. It poses the security risks. We saw a few breaches here in Australia related to the staging environments left open. If you use that, the data will diverge. And as I said, you probably don't want to spend money to run exactly the same resources as in production. The other one is static types and compiled languages. Right? People told me that it will save them. But I've worked with that kind of languages, and to some degree it's tests. Right? And you don't have your production data or load even in your Haskell. And also, if you're working, for example, with TypeScript, right, your third-party request anywhere, it's essentially any. You cannot guarantee the type safety there. The third one is the high load that comes often. I mentioned these examples that they've done with permissions and with the merge button. At that time, it was 6 years ago when they wrote these blog posts. They were serving 12 million developers. Recently, they celebrated much bigger number, and they still use scientists. So I think at least to the load of the GitHub, you will be fine. And to minimize the impact, if you're concerned about that, you can still use feature flags that we mentioned before and canary rollouts to run it conditionally on a subset of the users. The next one was a surprise even for me, that it's only for the refactoring. I was talking to my client that they've been using that, and I was checking on them if they need something. And they shared with me this interesting example. They have a couple of principal engineers that cannot agree on what is the best way to ship the new feature. And so they decided that even the new code, they will just ship both immediately, and they choose the one that is performing better for whatever better definition it is for them. So the next one is the side effects, which is the big one. It's not a myth per se. The scientist does not solve that for you magically. I also cannot tell you how to solve the side effects problem. If I knew, I wouldn't be here. And you need to be careful, right? But there's many techniques to do it with side effects. It's actually you check the observable differences of that, where you read it. And it's hard to answer all of the examples in the talk. So get in touch with my team at Visible Lights, and we would like to talk to you. And with our expertise, we can find a way to do it safely. And just again, as an example, we saw the GitHub where they was replacing the merge button functionality. And in my opinion, it's just a manifestation of the side effects, right? It's like you click that, there's an RPC call, there's I/O, there's a pooling, like there's so many side effects, and they're doing it. So I've been using the Scientist since 2016 and loved it so much that I've built a company around it. And one of the investors asked me once, like, why am I so excited to build around the Scientist and why I like Scientist? And for me, it's not often in, like, at least I am, like, in the industry, I read something and, like, find something new that it changes my life. It's something I couldn't done yesterday, and I can do now, and I use that regularly since then. So the name of the company is Visible Light, as I mentioned, and we are battery included service for the scientist, been built on top of it and with no strings attached. So if you value your core business and don't want to spend time and money figuring out the shape of these metrics that you want to send, where to store that, maintain the servers of that, build a UI around it, and maintain the security patches, we're here for you. If you still want to tinker and do it yourself, feel free to check our SDK implementations and talk to us. We love people who care about software quality. So yeah, please get in touch. So with that, this is Sagrada Familia thinking 1905, and that's what it is now. So with good engineering principles, we can make even the longest constructions projects to work. Thank you everyone for coming to my talk. Slides are on my website. I'll post them on Twitter too. Consider following me for my journey, and I'm happy to take questions. Thank you.
Thank you, Igor from Visible Light. Is there any questions? Anyone got any questions about Scientist, testing and production, Visible Light? Any hands up? I do have a question. Yes. Oh, we do have a real question, not a Michael question. All right. You want to just introduce yourself?
Sure. Hi, everyone. I'm Antoine, CTO at Stream. Yeah, just a quick question. I was thinking on the performance topic. Is there a way to make the experiment run asynchronously?
That's a great question. I'll just repeat that just in case. The question is, can you run the blocks like use and try asynchronously? It depends on the SDK and the implementation. The Scientist, the Ruby version of original Ruby version of Scientist does not support that out of the box. They decided that it's too complicated to build universal solution, but it depends on SDK. We want to implement that in our wrapper on top of Scientist, as well as if you at the Ruby conference, but use the different languages, Elixir and Haskell and like some other languages like Java, they do support to do them in parallel or concurrently. Thank you.
All right, and do we have any other questions? Michael had a question.
Yes, I did have a question. Can you try more than one block?
Yes, you do.
Okay, and does Visible Light, what does Visible Light do with the graphs then? Because then you're like matching multiple things?
Yeah, that's one of the reasons. We would be comparing against the use block, the different ones. So you will be looking at the diffs of your first try block that when you have multiple of them, you want to give them a names so you can compare them against your existing code with the named one.
Any other takers? Any last questions?
No pressure.
Thank you so much.
Thank you, Igor, Visible Light.
Thank you.